Okay, take two, guys, because I messed up on the first one. Today we're going to be learning about precipitation reactions in advanced chemistry. Well, to learn about them, you first have to understand what they are. It's a reaction where you mix two solutes and it produces a precipitate. A precipitate is a solid that forms in a solution. Typically, your solution is a liquid. However, if you mix two liquids together and a solid forms at the bottom, that is your precipitate. A precipitation reactions are generally going to be double replacement reactions, or you've also known them by double displacement. They also go by a few other names like exchange reactions or metathesis. Here's an example of a precipitation reaction that we have actually done in chemistry and that I've showed images of before. We have lead nitrate or lead 2 nitrate in its aqueous form. It's mixed together with potassium iodide in its aqueous form. And we mix those two together, they combine to make two different compounds. The first compound is lead 2 iodide. Notice here that it has an S, which means it's a solid. The solid means that this is going to be your precipitate. This is going to be your solid at the bottom of this glass. The second compound that is made is potassium nitrate, and this is in its aqueous form, so it's going to be the liquid that you see up here. The other thing I want to point out on this slide is it is a double displacement reaction. The lead, which was with the nitrate, is now with the iodide of the second compound. The potassium also switched places, is now with the nitrate. Precipitation reactions occur when pairs of oppositely charged ions attract each other so strongly that they form this solid. To predict whether certain combinations of ions form insoluble compounds, or other words, solids, we first have to understand solubility and the guidelines that are used to determine solubility for different ionic compounds. Before we look at the solubility guidelines, let's first define solubility. Well, solubility is the amount of substance that can be dissolved in a given quantity of solvent at a certain temperature. And these values in this table that we're looking at was all done experimentally. Scientists came together, performed a bunch of experiments in order to determine solubility and to make this table. One thing to know about precipitation reactions, and I have underlined it because it's important. I'm going to go ahead and star it because it's important. Whenever you are doing a precipitation reaction and you make the possible combinations and test to see if it's soluble or insoluble, if no compounds are soluble or if there is no solid, the reaction cannot occur. It doesn't occur because the whole point of a precipitation reaction is to make a solid, and if no solid's made, the reaction can't happen. Now, any substance with a solubility less than 0.01 moles per liter is often referred to as insoluble, or other words, will form a solid. And the reason is because the attraction between those oppositely charged ions are far too great, far too strong, where those water molecules or that solvent can't go in and separate those ions. This is a solubility table from the book that I used to teach this class, and we'll be using this table in class. The table is relatively easy to follow as long as you look at those exceptions. For example, the way you read this table is you want to look at your compound and see if it has any of the following ions that could be made. For example, NO3 negative is nitrate. If your compound contains nitrate, it is going to be soluble, and there are no exceptions for this. However, chlorine, if it contains chlorine, it will be soluble unless the chlorine is attached to a silver, if it's attached to mercury, or it's attached to lead. If it's attached to any one of these three elements, it automatically flips and goes straight to become insoluble. Same thing for down here. If you look at your compound and it has carbonate in it, it's considered to be insoluble unless it's attached to ammonia or alkali metals. So remember, alkali metals are your group 1 metals. So I'm going to write that down here. Alkali metals are group 1A metals. There is one thing I want you to add to this solubility chart, and if you get it in class, your notes, is NO3 negative has no exceptions and it's soluble. ClO3 negative and ClO4 negative are always soluble as well. So we're going to use our solubility rules and classify these ionic compounds as soluble or insoluble in water. I want you to try these on your own first to see how well that you do, and then we will go ahead and see how correct you are. Okay. So take the time, see how you do, and if you get it wrong, it's okay. This is learning opportunity. Okay. So let's look at number 1. Number 1 is sodium carbonate. So I'm going to go ahead and write out the ions. Na plus, and then carbonate is CO3 2 negative. I'm going to go ahead and write out the compound because, I like to do things like that. So Na2CO3. I have a sodium and a carbonate. So I need to go back to that table and see if they have any rules about that. So up here, I don't see sodium or carbonate. Oh, there's carbonate. So it says carbonate is insoluble unless it is with NH4. Well, it's not. Or if it's with an alkali metal. And you're going to see, yes, it is with an alkali metal. Na is an alkali metal, which flips it to be soluble. So here your answer is soluble. If you actually look down here and you understand Na and CO3 2 negative, that's exactly what this compound is. It's the same thing. So this is also soluble if you've gotten number 1. Number 2, lead sulfate. And I actually already found the compound for you. So this, if you want to split it into ions like we've been doing on our sheet, makes a Pb 4 plus ion and an SO4 2 negative ion like we've been doing in our sheet. So let's go see if we can find any rules about that. Oops. So if you look back here, I don't see a Pb. Oh, there's an SO4 2 negative. It says that it's soluble, but make sure you check those exceptions. It's not with a strontium, it's not with barium or mercury. Oh, it's with a lead, but it's lead 2 plus. Okay, well, it's not with a lead 2 plus. So if you go down here, oh, sorry, this is a lead 2 plus. If you go down here, it's with a lead 2 plus, which makes this insoluble. Didn't separate it correctly, Miss Justine. Okay. Down here, cobalt. I'm going to go ahead and write out the compound. So cobalt 2 hydroxide is COOH2, or it splits into CO2 plus and OH negative. So let's go ahead and see if we have any of these 2 ions on our chart. So I go down CO or OH. Oh, I have an OH here. I have to make sure it's not combined with ammonium. Nope, no alkali metals, and it's not combined to any of these 3 elements, so that means it's insoluble. So insoluble. Next, I have barium nitrate. So barium, so Ba, and Ba has a 2 plus charge. Nitrate is NO3 negative 1. So Ba, NO3, 2. Okay, so here's my 2 ions. I have to look if they're on the chart. Okay, so up here I look, I find NO3. It has no exceptions, which automatically makes it soluble. So this one you should have ranked as soluble. Okay, and then down here, ammonium phosphate. If you have ammonium, which is NH4 plus 1, phosphate, PO4 3 negative. So if I have ammonium or phosphate, if I look up here, okay, we get down to phosphate. It's usually insoluble, but since it's attached to ammonium right here, it makes it soluble. So this one becomes soluble. So how did you guys do? Okay. The next thing we're going to learn today is how to predict whether a precipitate forms whenever we mix aqueous solutions together. The first thing we have to know is what ions are present in the reactions, and then we have to figure out how those cations and anions are going to combine to make a double replacement reaction. The third thing we're going to do is we're going to use a solubility table to determine if those combinations are insoluble. Okay. So here's an example. The question says, will a precipitate form when solutions of MgNO3 or NaOH are mixed? Both substances are soluble ionic compounds, and both of those are strong electrolytes, so they will dissociate into their ions. So over here, I've split them into their ions. Mg has a 2+. This one was written incorrectly. This is NO3 -1. You have an Na+, and you have an OH negative ion, because I've separated all four. Next, what you do is if Mg is in NO3, you have to take that Mg, which is a positive, and combine it with the OH by crossing those charges. Mg, OH, 2. And then Na, since it's positive and it was originally with OH, needs to combine with the other negative. So NaNO3. Then what you do is you look at the solubility table and tell me whether it's soluble or insoluble, soluble or insoluble. When you look at the table, MgOH2 is considered insoluble because anything that is connected with a hydroxide are always insoluble or generally insoluble. Okay. So now we're going to try these. Again, I'm going to work through the first one with you, and then you're going to try the bottom two on your own. So let's work through the first one together. Let's split this into its ions. Well, it splits into, if I uncross it, Ba2+, Cl negative. This one splits into K+, SO4 2 negative. Then I have to flip them. Ba, which is positive, now goes with the negative. So you get BaSO4, because when you cross a 2 and a 2, they cancel. The other one you get is going to be K, because you always write the positive first, Cl. So then what you have to do is you have to look on the solubility table. So here I have an SO4, and I look down here, SO4. Then I look at my exceptions. Well, it's typically soluble, but my exceptions are if it's bonded to any one of these. And you're going to notice that it's bonded to a Ba, which makes it insoluble. So Ba, which makes this one insoluble. KCl, so I have a K and a Cl. I go down here, my Cl is soluble. K is not one of the exceptions, so this one's going to be soluble. So it's asking which one's the precipitate or the solid. This one is going to be your precipitate or solid. Okay. So what I want you to do is pause this video and try to figure out for the last two if it will have a precipitate or not and which one is the precipitate. Okay. So let's kind of get started and figure out how you did. Okay. Over here, if I uncross my charges, this one makes an Fe3+. This makes an SO4 2 negative. This one splits, you get an Li plus and an OH negative. So now I have to recombine this positive and this negative. Fe, put the parentheses around it, 3. This one has to combine. Li2 SO4. Now I look on my chart. Which one's insoluble and which one's soluble? Well, I have OH and iron. So I go down this table. Well, OH is here, and then I have to see, is iron one of my exceptions? Nope, so that means it's insoluble. Over here, lithium and sulfate. So I go back to my table. Oh, there's sulfate, but lithium's not one of the exceptions, so that means it's considered soluble. So it's asking, when you form it, which one's the precipitate? This compound is going to precipitate. And the very last example, I want you to try this one on your own, and then we'll see how you did. Okay, let's go through the last example. It's asking, will a precipitate form? So let's go ahead and split these into their ions. A Ba2 plus, NO3 negative. This one splits into a K plus and an OH negative. Okay. Now I have to rearrange these and combine them. So this positive now goes with this negative OH. So BaOH2, the K, and O3. So let's look at the table and see how we do. First ones we're going to look at is Ba and OH. So down here I go down. Oh, I see the OH. Ba is one of the exceptions, so that means it flips it up here and makes it soluble. Okay, so this one's soluble. Okay, and then I have potassium and NO3. So if I go down to my table, oh, I have NO3. There's no exceptions, which makes it automatically soluble. Notice here that I have no insoluble, so no precipitate will form. No precipitate will form would be my answer. So no reaction can happen. Okay. And that's the end of today's lesson. If you have any questions, make sure that you're asking them. And yes, you will refer to this guideline. These guidelines, solubility guidelines, are on my website. There's a link for them. So make sure that you're opening up and using these solubility guidelines. Don't forget in your notes that also on these guidelines, ClO3 negative and ClO4 negative are always soluble. There are no exceptions for it. So anyways, I hope you guys have a good day, and let me know if you need anything.